In this video, we're going to take a look at questions 35 and 47 from section 5.1 and give you some solutions to those, more ideas to help make these verifying of identities a little bit smoother and easier for you. So let's take a look at 35. So we start with, we're trying to verify this identity. Many of you asked me which side to start on. Honestly, you probably want to do a little bit to both sides and start to simplify it in that way, because secant, cosecant, and tangent really don't have much in common besides sine and cosine. So I'd start by taking both of these and changing them to sines and cosines. So we'll have 1 over cosine x minus 1 over sine x all over 1 over cosine x plus 1 over sine x. I'm going to do the same idea to the right side, but of course with the tangents. So I'm going to convert the right side to sine x over cosine x minus 1 all over sine x over cosine x plus 1. So in doing this, I can see some similarities and some differences between these two sides of the function. We're going to do what's called meeting in the middle, and I've mentioned this to many of you as well. Meeting in the middle, you're going to do a little bit on the left, make it simpler, do a little bit on the right, make it simpler, until you meet in the middle and realize these two sides are equal, because you've created a complete path from point A to B when you meet in the middle. So I see on the left, I really don't like all those weird denominators. So on the left, in this equation here, I'm going to take everything, and on top and bottom, I'm going to multiply by sine x, cosine x. And I have to do the same thing to the bottom because I'm essentially just multiplying by 1 when I do this. Now this is helpful because I have to distribute to both of these terms sine x, cosine x, and to both of these terms sine x, cosine x. That's my somewhat common denominator, which will allow me to cancel all of my denominators. So when I distribute and multiply this times this, I'm going to get the cosine x's canceling. And in the numerator, I'll simply have sine of x minus. Now I'm going to do the same thing with the next term, but instead of having the cosine x's canceling, when I distribute to this thing to the second term, I'm actually going to have the sine x's canceling. Those are going to be gone, and I'll be left with minus cosine x. Much easier to look at here. Now on the bottom, it's something very similar. The second set of parentheses, I'm going to have, in the bottom, I'll have cosine x and cosine x canceling for this one, and I'll have sine of x's remaining. And the same thing, the same idea with the next one, but of course it'll give me the sine x canceling, and I'll have plus cosine x. So this is just much easier to look at, much cleaner, much easier to deal with. I'm going to do something the same to the right side, and of course I'm not changing any values. I'm simply manipulating it and changing the look of the fraction, and I'm going to do something exactly the same, but in this case I'm just going to multiply by cosine of x on top and bottom, because that's the only denominator here and here that I want to get rid of. So this will allow me to get rid of that for both of those terms. So the cosine x distributes to both terms. When I do cosine x times 1, that's easy. It's just cosine x. When I do cosine x times sine over cosine, the cosine x's will cancel and I'll get sine x. Do the same thing on the top. Same thing will happen for this fraction. And same thing with this one. But in this case, it'll be sine x minus cosine x. I've not changed any values by adding on something. I've only multiplied by 1 on the left side and on the right side of my original identity that I'm trying to prove. I'm at the middle point because I see I have the exact same thing, the left and the right met in the middle, and I can see that they're equal. I can be done at this point because I manipulated each side separately and realized that they are equal in the middle. So therefore I could finish the process and go forwards or backwards to go all the way, but I've created a complete route and I'm done with this problem. Let's take a look at the next one. The next one that was a tough one for many of us, and even for me the first time, was verifying the identity for 47. So secants and tangents, some of our instincts are to change things to sines and cosines. And even I did this the first time, but if I also look at my identity sheet, I see an identity that says 1 plus tangent squared of theta equals secant squared of theta. So I see, this is the Pythagorean identity. Double check your formula sheet in the back of your book. So I see that secant and tangent are quite related. So I'm going to leave these as secants and tangents for now and see what I can accomplish. And once again, the opposite sides are equally complicated. So I'm just going to pick the left side to start with. And I see, number one, in my final result, I see tangent of t on top. So I'm going to give this a shot and maybe just times by tangent of t on top and bottom. Not sure if this will get me anywhere, but it does accomplish the goal of having on the top a tangent t term, and that's part of my goal. So that's going to help me at least get halfway there. I got to figure out how to cancel everything else, but we're halfway there. I'm going to leave the top as a factor because my ultimate goal is to get rid of secant of t plus 1. That's my ultimate goal here. In addition to that, I want to get secant of t minus 1 in the bottom. So let's see, I'm going to have tangent squared of t. Taking a look at my Pythagorean identity, I can change this tangent squared to something related to secant up there. That will allow me to get rid of the tangents in the bottom, and perhaps the secant t minus 1 will appear. So let's see, if I subtract 1 from both sides, I have an equation that relates tangent squared of theta to secant squared of theta minus 1. So I'm going to replace that here. So I have tangent t times secant of t plus 1 all over secant squared of, how do I put theta? No, t. We want t here. Secant of t minus 1. So I'm getting closer. I am getting rid of tangents that I don't want, and now I need to figure out how to get rid of secant of t plus 1. The only way I could cancel that is if I had the same thing on top and bottom. So now I look to the bottom. It is not a product, it is a difference of secant t squared and 1. So I need to create a product in that. So I'm going to go and factor secant squared t minus 1 into two terms. They will be secant t minus 1 and secant t plus 1. This is a difference of two perfect squares here. Think of secant t as a squared minus 1 squared. So the difference of two squares can always be factored as a minus 1, and in this case a plus 1. It's always a difference of two squares, and you have 1 plus and 1 minus. That middle term that we are missing will cancel because they will be identical and they'll be opposites. Now the top I'm just going to copy down and notice what I can cancel. I'm canceling. My final step is going to be to cancel the secant t's from plus 1 on top and bottom, and I see my goal. I've arrived at my end. I have left secant t on top and secant t minus 1 on bottom. Now there are multiple ways to solve this problem. In fact, the first time I solved it on my own, I solved it in a different way. I solved it by timesing by secant t minus 1 on top and bottom instead of tangent t on top and bottom. And that will work as well in a similar manner. But factoring is your friend whenever you're trying to cancel from top and bottom. So hopefully that helps you a little bit, get started on some other ones, and get through these two at the very least. Bring in your assignment tomorrow so we can go over it.